Okay, so, and here is what you're waiting for. Okay, so this is the homework. Okay, so our homework will be about the system that looks like a U-shaped wire, and there's an electric current I flowing through the current. So we suppose that this side is infinitely long, and also the other side is also an infinitely long. Okay, and at the end of the hairpin, okay, we have a semicircle of radius r, and the center is at the point A. Okay, and the point B is in the midway of an infinitely long wire. So actually, this part is very long, this part is very long, and we have B at the middle. Okay, so this is how it works. And they ask you to find the magnetic field at A and B, right? So the guidelines for you is to watch back to our videos about using Biot-Savart's law to find the magnetic field at the center of a circle. Okay, and so if you consider magnetic field at the center of the circle, this is the integral that you come up with, and you are going to have the integration of the circle, the integration along the circle, so that you have the circumference of the circle 2 pi r, and finally in example 1 you come up with this relation. Okay, is the magnitude of magnetic field B equals to mu I over 2r. Okay, so in this example we are going to use the ideas of the same idea to solve for the magnetic field from a semicircle. Okay, so if it is a semicircle, okay, you need to have a look at the change on this integral. Okay, so if it is a circle, the integration along the curved path is 2 pi r, but for a semicircle, should it just be pi r? Okay, so please have a check. And then for the other parts, we have considered the solutions for the infinitely long wire. Okay, so we have shown that for an infinitely long wire that having current I, so at the distance r from the wire, we found that the magnetic field is mu I over 2 pi r. Okay, then for half infinite, okay, so the technique, you can have a look back at the video about the straight line. So the technique is to substitute difference lower and upper limit, or substituting the two ends of the wire. Okay, so if one end is at infinity and if another end is at 0, what is the magnetic field going to be? Is it going to be just simply half of the magnetic field? So please have a check. Okay, so after you have the solutions, your solution for this half infinite wire, straight wire, and half circle, you tends to put them together. Okay, so if we are considering point A, so we might have the magnetic field from part 1, which is the half infinite wire, and the part 2, which is a semicircle, and part 3 is another half infinite wire. Okay, and for the magnetic field will be the summation of B1, B2, and B3 of the 3 parts. And what you need to be aware, what you need to be careful is the direction, because all of them, B1, B2, and B3, they are the vector quantities. Okay, so you need to look at the direction of the current here, and if this part 1 has direction of the current to the left hand side, what would be the direction of the magnetic field at A? And also for the part 2, if the direction of the current goes counterclockwise, what would be the direction? So use the right hand rule to do that. Okay, and also for part 3. Okay, so if you get the magnitude and the current, just add them together. And then for the point B, okay, I would like you work out on this. Okay, so whether you are going to use infinitely long wire or use half infinite. Okay, you need to think about that, and also whether to treat some of the part as 0. Okay, so this is what I can tell you. So and the deadline of the homework will be tomorrow.